Okay, I think we're good. Yeah. Okay, welcome everybody. Welcome on in. Hopefully, we'll get we're a little low, but the first few minutes we always have people kind of streaming in, and that may be the reason that some students miss information. If you come to and I'm talking to the people who showed up here on time, so that's. But there's certain things that just have to say at the beginning of class because they don't really fit in the middle. If you show up 5 or 10 minutes late to one of these meetings, I would encourage you, go back and watch the first 5 or 10 minutes. You would probably be surprised how much information about certain things is given in that first 5 or 10 minutes. And if you don't have that information, then you might end up not knowing what's going on, right? Which is going to obviously work against you, right? So, we're what here? Your survey questions are due tomorrow, which is October 5th. Okay, so I want to talk about that because in my other stats class, the one that the 18-week class, even today I got an email this morning asking why didn't I get questioned for survey questions, and when I went and looked, she hadn't posted anything in the discussion. Right? So I know I sound like a broken record going over this kind of stuff, but I'm hoping each time I mention it, a few more people will sort of understand how this works. These are discussions, right? You get points for the discussion. If you don't participate in the discussion, you don't get points. So if you want to get points for the discussion, you have to have a meaningful post or comment in the discussion, right? There's kind of a logic to that. Why would you get points for a graded discussion that you didn't participate in? You aren't. And I know you formed groups to help each other, but remember, you're each doing your own project. You each are going to turn in an individual project that you made. Now, you're going to help each other with it along the way and help each other figure out how to do stuff. But you're each going to turn in your own project, and you each need to be doing the discussions in order to get credit. And it says here, the first line, each group member must leave a posting in order to get credit. I know a lot of people don't read directions. You should, right? That's kind of a college expectation, is that you read the directions here so that you know what you're supposed to do. If you skip all these directions, then you're going to not know what's going on and you're going to miss out on points. I don't like giving people zeros, but you have to follow at least the basic directions and kind of have the basic understanding of what's going on in order to get those done. So we only have 2 posts. I realize that, the defense is, well, it's not due till tomorrow. Okay. Generally, you don't want to be waiting till the last minute to do stuff, right? You'll hear me talk a lot about procrastination in this class. That's fine that you haven't posted them. They're not due till tomorrow. Make sure you get them in by tomorrow, right? And that doesn't leave you a lot of help to get feedback on the questions that you're trying to turn in. So I just want everyone watching this video to understand, and then it's archived so that later when people miss this information, you go back and see, oh yeah, he did say it like a dozen times. If you do not post in here, you will not get points. And even when I say that, students say, oh yeah, but my group member posted and she said my name. It's like, don't try to change the directions that I'm giving you into something different. What I'm saying is, if you don't leave a post, you will not get credit. All right. Don't make up like another part that says, oh, unless my group member mentions me. No, that's like, don't change the directions. The directions say leave a post in order to get credit. It's just a lot easier if you do that instead of trying to change it into something different. Okay. And I'm not trying to be rude or condescending or anything. It's just, this is a lot of people, not a lot of people, but there's sort of continuing to be people that don't understand why they're not getting points for this. Each discussion, if you want points, you have to say something in the discussion. Okay? So please do that. And I did want to actually talk about, so there's only 2 people have posted their questions, and I wanted to give feedback to those people a little bit. I had hoped there would be more so I could give a little more feedback. But again, it's this discussion we're having about creating good problems. And I'm not picking on these people, so I hope they don't feel like I'm picking on them. I'm actually trying to help here. So I'm not going to show their names or anything because I don't want people to feel like they're being soloed out or anything like that. In fact, my commendations to the 2 people that left postings in here. They're the only 2 people in the class so far that have actually turned in the assignment, right? So, and I get there's another 24 hours or whatever, a little over 24 hours to turn these in. But so to those 2 people that who's I'm going to use as an example here, I'm not picking on your questions. These you actually did a good job, but I just want to talk about some of these things so that people who are still working on their questions will have a better idea. So to those 2 people, good job, right? Pat yourself on the back. You did very good by getting these in here. And obviously you spent some time thinking about these. So when I'm kind of dissecting the questions and giving some suggestions, don't take this as you did a bad job. It is hard to learn how to ask good questions in statistics. That's the whole reason we're doing this, right? Is as a learning exercise so that you can learn how to do it. So I'm just giving a little bit of feedback. It's part of the learning process. It's not that you didn't do a good job. It's just, this is your first attempt at doing this. Both attempts that I'm seeing here, obviously effort was put into it, but I'm giving you some feedback so that maybe you can make it a little better because as I mentioned, it's really worth having good questions at the beginning because once the survey's taken, you can't change that. You're stuck with those questions for the rest of the semester, and you're going to have to make them work. So the better your questions are, the better the whole project's going to go, right? If you have really good data, the rest of the project's going to be a lot easier than if you have to go through and try to figure stuff out. Like there's a question, how tall are you in feet? I would recommend using inches as a unit for height. Only because if you ask people their height in feet, then they're either going to say 5 or 6, and maybe the occasional 7. That's usually we're a little bit more specific when we ask about height. So with the feedback I'm giving, you might want to come in here and just edit these a little bit so that the questions are a little bit, you'll get better data, right? So I would just change that to how tall are you in inches, I think is probably a better go of it. And then there's a question, what shoe do you prefer? I would say that's a good example of, I'm sure when the person wrote that question, they were really, they knew what they meant, but then you have to also put yourself in the mind of the reader who is reading your survey and think, do they understand what I'm asking? So when you ask like, what shoe do you prefer? I can think of 2 major ways that people would interpret that. So you're probably going to get 2 very different types of answers, right? One is people will interpret this as, what shoe brand do you prefer? So you're going to get people saying Nikes and Adidas and, someone might even say Crocs or, whatever. Whatever kind of shoe brand people prefer, they might put that. Whereas other people might interpret that as the type of shoe. So for instance, someone might say, trainers, or I like running shoes. I like basketball shoes. I do track. And so I have like my actual track shoes or whatever. So I would say maybe just clean that up to make it a little more specific if you're asking about the type of shoe or if you're asking about the brand. But that's actually a good question. Do your feet hurt after walking for a long period of time? Good question. How many of you in the class got the vaccines? We can just sort of streamline that a little bit to, did you get the vaccine? Because technically the question is asking how many of you in the class got the vaccine, but each individual doesn't know how many people got vaccinated. You're actually asking the individual, did you get the vaccine? So that I would say that's a little bit of a sleeker way of making that question is, did you get the vaccine? Have you been vaccinated, right? And then what kind of vaccine did you get? In that case, I would probably give them the 3 options, right? What kind of vaccine? Do you mean what brand? So we're back to the kind again. So if you mean brand, what vaccine did you get? Pfizer, Moderna, Johnson & Johnson. I think that's the only 3 that are out right now, right? Give them those choices, and then people can choose. Did you get any symptoms from the vaccine? Good question, right? Okay, are you currently employed? That's good. How many hours do you work per week? That's good. How many times do you eat out? Good. That's good. Oh, so the only thing I would change here in this other group, it says indicate which age group suits you. I'm not sure if I 100% understand. When you say which age group suits you, do you mean that's almost like a preference? Like which age group do you prefer? And then that sort of begs some more questions. So if you're asking what age people are, I would recommend just ask, what's your age? And then people can write that, and then you can split them into whatever groups you want. If you're making your frequency table or your histogram, you can pick those different bin sizes. If you pick the bin sizes early on, you're sort of limiting yourself. But if you know all the ages, then you can put them into whatever groupings you like. Okay, so that's what I would recommend. So again, to the 2 people that have left comments in here, good on you. It's like a home run basically, because you've turned in the assignment. And I'm giving a little bit of feedback, not because you did poorly. Pretty much everyone's questions can use a little bit of feedback. This is the first time you've ever done this, so so good on those people for doing that. Okay, so where am I? Right, I do have office hours today, so feel free to come to office hours if you want to try to ask me your questions. If you're in a group that still wanted to ask questions, I do have office hours tomorrow as well during the day, the Zoom office hours, so you're welcome to go to any of those. Okay, so everyone understands, and a couple more people came in there. Hopefully everyone understands. For the discussions, if you don't leave a posting or a comment in the discussions, you don't get credit. Okay, so just make sure you understand that. Okay, where were we? We left off last time. We were talking about like the basic shape of data, and we're looking a little bit at like visualizations of stuff. So where was I? There's a question here. Do you prefer we email you or come to office hours for feedback on our questions? Okay, great question. So students asking, do I prefer an email or that you come to my office hours? I mean, I find in general a discussion is more helpful. So if we can discuss it either at my office or over Zoom or something like that, then that's usually, I think, more educational for the student rather than me sending back an email. So I would prefer that you try to meet with me during office hours, so either in Zoom or on campus today. Right, that would be the preference, but if you can't make that work, then try an email, and I can give you, basically in an email, I'm probably not going to be able to give you as much feedback, because otherwise it just goes on, and long emails tend to not get read by students. So I can give you some feedback, but it's, I'm probably going to be able to give you better feedback if we're actually having a conversation, right? That's generally how it works. So whatever works for you, right? Either way. Okay, so we're looking at a few things here. We were looking last time at the shape of data. We looked at a few different histograms. I believe we were just getting into the histograms. So remember, the way this works is the main source of information in this class is these lessons that you're getting along the way that are teaching you these individual lessons. What I cover in class is only a small fraction of that, because we only meet 2 hours a week. That's 30 hours of the course of the semester. That's like 40% of what we'd normally meet. So remember, you're not going to get everything in class. You're going to get it from these lessons here. I'm just filling in, and what I'm trying to do is give the depth a lot of times. So a lot of times people look at these topics and go, okay, I have that memorized. I know what this is. I can make StatCrunch do it. But they don't really understand what's going on. We want to reach for that understanding in this class. Otherwise, everything is it's just a silly exercise of making you run around and do things that aren't really going to be meaningful, because you won't really understand statistics at a deeper level. So that's where we're going with stuff. So your groups, make sure you get those survey projects in, the questions in. Don't Don't forget, or you might end up not having your your questions won't be included in the survey. Okay, so let's see, where was I? That's that, right? Make sure everyone leaves a posting. We don't need that up anymore. We've got StatCrunch. Okay, so I want to give you, I ran out of time last time, but I wanted to talk about the shape of data. Remember we talked about that? It was basically, oops, that's for later. I think we showed this picture. If I try to move a few pages at once, it jumps like 20 pages. But remember how we kind of saw these are actually the same shape, but we want to look at, here we go. We talked about last time how our data can take different shapes. This is a roughly normal distribution. It's bell-shaped and more or less symmetric. You're never going to get real-world data that is exactly symmetric. But you can kind of make the case, yeah, pretty much if I fold this over onto this side, it's more or less going to line up, right? This is what we call a uniform distribution. That means all outcomes, like this is what you get when all outcomes are equally likely. We'll look at this in a minute. When you roll a dice, you expect to get as many 4s as you do 5s. Not exactly. If you roll a dice 1,000 times, you're probably not going to get the exact same number of 4s as 5s, but they'll be pretty close to each other. This is the kind of thing you expect when all things are equally likely. You can have your data skewed to the left or skewed to the right, and this usually means you have some sort of external force causing this tail to not go down as much. Like the example I give is ages of students at the college, right? We don't see a ton of people in their mid-teens. There's some 14-year-olds, 15-year-olds, 16-year-olds, 17-year-olds, but the majority of people come in at 18, 19. So we see a huge jump, and then you have the ages going a long ways in the other direction, right? I've had people that are almost 70 in my classes. Good for them. And so we get this tail. So whenever you see your data skewed one way or the other, just ask yourself, I wonder why that data is skewed. Can I come up with an explanation as to why my data is shaped like this? And if you can, great. That's exactly what we're looking for in this class, is a deeper understanding of statistics, not just memorizing it. Okay, so that's kind of where we left off last time. And we did do an example I wanted to show you up here with the, we had a frequency table up here for pennies. Yeah, remember we talked about the gap? And we talked about, so this is one way of representing our data. And there was a gap here. And that gap, it caught our attention, or it should have caught our attention and go, wait a minute, there's a lot of pennies here, this weights, a lot of pennies up here, these weights, and there's 0 in the middle. That's weird, right? And so then as we investigate, we would be able to explain this gap by going, oh, now that we've looked into it and we've read the Wikipedia page about pennies, we know that they changed in 1983 the way they made pennies, which means the pennies now are a little bit lighter than they used to be, right? So now we can explain this gap. So anytime you see a feature in your data that looks like it's not like just, random simple sampling error or something, you look at it, you go, that seems significant that there would be none in the middle. There's probably a reason why, and you want to try to explain it. So I brought that up again because we're now going to start looking at different types of graphs that we can look at. And we looked at the histogram last time. Let's see, what if I just do it? This is probably a little quicker. Okay, here's the pennies again. This is what we call a scatter plot. You will want at least one scatter plot in your project, because the scatter plot is going to be part of your visual representation for your correlation part, which we haven't talked about yet. So if it's making you nervous that I'm using words that you don't understand, that's totally okay. We haven't talked about correlation, but we will, and you really should include it in one way or another in your project. Right? If no one mentions if your whole project doesn't mention correlation at all, I'm going to scratch my head and go, I wonder why they didn't mention that. That seems like maybe that's a deduction right there. And this is why you want to watch closely, right? I've kind of talked about, more and more we're getting people not reading directions and stuff. We're sort of seeing this across the board, or people not reading directions when they do assignments. Remember, in those questions, I tell you specifically, have at least 2 quantitative, at least 2 qualitative, and then 1 yes/no question. The reason that's the minimum is because if you do not have at least 2 quantitative questions, you can't make a scatter plot. And if you can't make a scatter plot, you can't talk about correlation. And if you can't talk about correlation, you're basically going to have an incomplete project, right? That's a pretty major topic in the course that you're just skipping over. So make sure you have 2 quantitative questions so that you can do something like this. And you'll put a line through it. We'll talk about those lines later on. But this is a scatter plot. So see, we've got over here, we've got years. And over here, we've got weights. And notice that when, this gives away, now that we're in, when we had the frequency table, it was just about the weights, right? And we saw that gap. But notice how when we put these 2 statistics together, the weight and the year, all of a sudden we go, oh, I see what's going on. There's something very different about the pennies made in 1983 or later than the ones that are made 1980 or earlier. There's a very different. So that would lead us to go, oh, okay, what happened in 1983 that made pennies different? And then we could look that up, 1983 pennies or something. And then probably what we're going to find is some kind of information that's telling us, oh, in 1983, pennies started being made differently because it was cheaper. So do you see how that works? Do you see how it's not just a matter of blindly putting a scatter plot into StatCrunch and going, okay, I'm checking that off the list. I've got my scatter plot and I'm moving on. We want to investigate what the data means, what is actually going on here, okay? And this is a good way. I would call this a great way of representing that data because it makes it very clear. There is a big difference between the pennies made before 1983 and the ones made after. Okay, so get comfortable with scatter plots. Make sure you ask 2 quantitative questions, or you're going to have a gap in your project. Okay, time series graph. These don't come up as much. Just they're sort of intuitive to read, but I wouldn't worry about it too much. Use one if you want, right? Some of these I'm not going to go over as much just because you're not as likely to run across them regularly. Use a time series graph if you want. You don't have to. Most students don't. Dot plots are helpful. Okay, so a dot plot is basically where you just have your numerical, grid, your axes, and then above that data point you just put a dot. Let me see if I can make this a little bigger. Let's do that. See, so you have these dots. So it's giving you a different way of visualizing the data, right? Most of the time, a lot of the time, people end up preferring a histogram to a dot plot, but a dot plot sometimes might be the right tool, right? Depending on what you're doing. But it gives you that shape. So you can feel free to use those. And some of these I'm going over briefly because they'll get talked about in the lessons that you're doing. The stem and leaf plot represents quantitative data by separating each value into 2 parts. You should know how to read these, but I will tell you these, I almost never see people actually use these, and I never see them in the wild either. But just so you know, the way you, went to my whole screen there. The way you read these is that this number over here on the left of the bar is like the beginning of the number, and then these digits over here are like the ones digits. So see how we have a 5 here and then a 0 and a 6? The 0 stands for 50 because it would be 50. And the 6 stands for 56 because it would be 56. So that represents 2 data points, 50 and 56. So down here you'd have what? 70, 72, 73, 74, 75, 76, 76, 76, 76, 76, 77, 77, 78. Now why would we do that? Well, this is one of the considerations that we want when we visualize data is, can we get back to the original data points? A stem and leaf plot allows you to go back and get your original data, right? Like if I just hand you a pie chart, you can't go back and figure out what the original data is, right? But if I hand you a stem and leaf plot, you can. because you go, oh, I see. This would be what? 111, 115, 115, 118, right? So you can read the data points right from there, which can be helpful, but this is another one that's not used a ton. Bar graphs are good. Make sure you know the difference between a bar graph and a histogram, because people mix them up, and there's there's some issues with them. Here's where you can do a multiple bar graph. Whoops. It's a little too big now. You can do two different bar graphs at the same time, side by side. We've seen these graphs. Sometimes these end up these actually get used quite a bit for different things. It's if you're trying to compare things. So we see these graphs at the college. We're always trying to improve success rates. What can we do to make sure that students are successful at the school? And then one of the things that comes up is, what are the different pass rates by race or gender, right? And because if you a lot of times there's a gap there, right? And you want to try to make changes at the college. This is a discussion that goes on a lot. You want to try to make changes to make sure that everyone is being successful, not just certain people are being successful. So a lot of times we'll see in meetings, we'll see these where the bars represent different races and pass rates and stuff like that, and then we'll go, oh, well, maybe we're not serving certain groups of people well, right? What can we do to make sure that we're serving all of the groups of people at our school so that we get the pass rates up where they need to be? And this is the kind of chart that we'll see in those kind of meetings where we say, okay, how can we do better, right? What can we do to do better, right, for different groups that exist at the school? So those are actually quite helpful. Feel free to use the multiple bar graph if you want. Do know the difference between a bar graph and a histogram? So let's take a look. A bar graph uses bars of equal width to show frequencies of categories or categorical qualitative data. So remember, the histogram is more for quantitative data, and generally it's more continuous, where your bars can actually touch each other. In a bar graph, they should not be touching each other, right? They should be separate because these are different categories. Like it could be eye color. So you have like the different eye color right here. In a histogram, it makes sense. If we did a histogram of ages that goes from, say, 14 to 80, it's a continuous, like you move to the right as you age, right? It's a continuous variable, whereas eye color is not, right? You don't go from having your eyes get more and more green and then all of a sudden they become blue. And then as your eyes get blue, 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 all of a sudden they become brown, right? That doesn't make sense. So that's why we have this gap in between the bars in a bar graph, because they are different types of data. That is a major mistake I see people do when they make a histogram or a bar chart, is they will either have a histogram where the bars are separate, or they'll have a bar chart where the bars are together. So make sure you're paying attention to which type of data that you're dealing with. Okay, so you know which one to use. Should I be using a bar chart or should I be using a histogram? Pareto charts are kind of nice. They're just a variation which allows us to basically put things in a nice order. So Pareto chart sounds really fancy. All it is basically you have a histogram, but you put things in order from either, I think a Pareto chart has to be highest to least. So you start with, because if they're all mixed up, sometimes it takes you a second. You have to look around and orient which ones you think are the high ones. Here we've got, we can see, family partner is the greatest one here. So this is what contributes most to happiness? Okay, so for most people are saying it's the family partner, then friends, then leisure, work, music, sports. So we can see it go from, it's already ordered from most influential to least. That can be helpful. You'll also sometimes see where they switch it around and it goes from least to greatest, but usually you're going to see greatest to least. So when you're making a histogram, that should always just be a question you should ask yourself. Should I put them in order from greatest to least? Because the answer frequently will be yes. Organize your data in this way. It's just a little bit more organized, and it's already sort of ranking everything, so you can see which ones, which ones need they're already ranked, so you don't have to go back and rank them later. Okay, pie charts are a big one. People like to make pie charts because they've seen pie charts. I think there's way too much emphasis on pie charts. People go to them more often than they should. In fact, this particular book, like the book we're using, is not quite so down on pie charts. But I mean, this book right here, which is the most used stats book in the country, never use pie charts because they waste ink on components that are not data and they lack an appropriate scale. So basically, this author, the most widely used author in the country for statistics, is saying never use pie charts. Now, I'm not going to go so far as to say you should never use a pie chart, but oftentimes it's not as good as people think it is, right? And this isn't a very good example of what I'm going to show, but you'd be surprised how hard it is to compare these sizes. A lot of times you'll have sizes of these pies that look similar, like right here, leisure and work studies. Are those equal? It almost looks like work studies is slightly bigger than leisure. I can't quite tell. And how much bigger is friends than work studies? Is it 2 times? Is it 3 times? It's really hard to judge these pies, right? Whereas if you threw them in a histogram or a bar chart, right, you can tell by the height of the bars, you get a pretty good understanding of how much taller one is than the other. Okay, so that's you can use pie charts in your project if you want. You're welcome to do that, but you probably should be ready to have a good reason why you used a pie chart, because they a lot of times, like, people think that looks really professional, that looks really good, but there's better ways of communicating your statistical ideas than that. We've got frequency polygons, which you probably aren't going to use, and then multiple ones. Okay, then we get to graphs that deceive. So there are ways in which you can do a graph poorly, which will either intentionally or unintentionally mislead the people who are looking at your graph. Okay, so you don't want to do that, right? You want to, first of all, do a good job, and you want to be ethical, right? Like, cigarette companies, when they put out data, they're misleading intentionally. They did that for years, where they were intentionally misleading because it made them a lot of money to do that. We want to be able to present graphs where we are communicating the information and we're not trying to cheat. We're not trying to trick people out of stuff, right? And one of the best ways to do that, make sure your graph is always well labeled. The x-axis is labeled, the y-axis is labeled, the units are there. Everything that someone could ask about your graph is already there, right? It's all taken care of. So, like, that's kind of the test. If you hand someone a statistical graph and they have to ask you what something on the graph means, you didn't do a good job, right? Label everything. Another big one is a non-zero axis. Having a not including the non-zero, the zero in your data is a big way to mislead people. Some people can leave the zero off on accident, but I'll show you. We're going to look at some real-world examples of stuff, and you're going to see that it's actually quite misleading. So let's see. I'm going to have to make this a little smaller. Here's kind of the made-up information, but we'll look at some real-world examples. When I look at this, what does your brain tell you? Well, it tells you that this bar is what? About 5 times higher than this bar, maybe 6 times. This one's about, 3-4 times higher than this one? So you're like, man, what is this? Highway fuel consumption with vertical scale, not starting at 0, but this is highway fuel consumption. So highway fuel consumption in miles per gallon. Okay, so we're looking at miles per gallon. Your brain is immediately telling you the Honda Civic is like 6 times more efficient than the Camry, right? You're going, man, for every time I fill up with the Camry or with the Honda Civic, I'd have to fill up 6 times with the Camry. That's wild, right? Yeah, because it's not true. If you look at the over here, oh, it's really the difference between about 31 miles per gallon and 36 miles per gallon. That's not 6 times, but that's what your brain immediately sees when you see these bars where one bar is 6 times taller than the other one. This is the right way to represent this data, where you have a 0 in there, because see how you see it now? Oh, the Honda Civic is more efficient than the Toyota Camry, but only a little bit, maybe 10%, right? Not 600% like your brain immediately thinks. Okay, so let's look at some real world examples of this. If you're ever trying to look these up, there's one particular news agency that is absolutely known for terrible graphs. You can find bad statistical graphs. If you want, you can find them on CNN and MSNBC. They all make mistakes at times. But there's one, I don't want to get into politics here in class today, but there's one news channel that is just, there's entire websites dedicated to picking apart the intentional dishonesty and then also just incompetence that are done with the statistical graphs on a certain channel. So right here's our pie chart, right? This pie chart, this pie chart isn't even meant to trick you. It's just wrong. It's just done poorly, right? How can we have more than 100% inside of our pie chart? That is not how a pie chart is done, right? That is in no way. Also, your source should never be opinions. That's kind of always the case. You need to be citing specifically. So what they should have said, if Dynamic is a company that does polls, they should have said a dynamic poll and then sort of directed you to that poll, right? So this is just done wrong. So don't ever do this. This doesn't even make any kind of sense. Okay. But to what we're just talking about, here's a good example of how this gets done. You see this done all the time. Here. You don't use the 0, and so it makes it look like this is a huge difference compared to this thing over here, right? So a 35% tax rate versus the almost 40% tax rate. If you don't actually look at the numbers, your brain automatically gives you like that feeling that this is like 10 times what this is over here, right? In this case, they actually gave a scale, which is at least good, but it's a lot of times you give people that emotional, like that thing they get when they look at something and they get an emotion. That's gonna, like, they're never gonna get to the point of breaking it down intellectually. They're just going to go with that emotion and go, man, look at taxes are going to be 10 times higher. Are you kidding me? That's crazy. And then also, it's weird that you would put the numbers on the right unless you specifically don't want people to look at them. How many times have you seen that, right? Almost always your vertical scale should be on the left because we read from left to right. So you put something at the end if you kind of want to hide it a little bit. That's not really considered great. Right, let's see. There's a few. Where's the other one I wanted to do? There's a bunch of ones where they use that. Maybe it's on a different page. But that's an example of, see how they're not using the 0 and it exaggerates this difference, which is really only about a 4% difference, but it looks like it's a much larger difference. And you could spend all day finding examples where this happens in the news. Let's see. I want to make sure I click the right one here. Where do I want to get back to? Right here. Here's where I want. So see, that's just sort of that's a real world example we just looked at of this right here, using that 0 scale. Now there are a few times where it just doesn't make sense to use 0 as the scale, but then what you're supposed to do is put something over here like a squiggly line or something that draws attention to the fact that this is not the whole scale. This is not 0. Like over here, this is not 0 to 40. So you generally put a squiggly line or something in there to emphasize that, so that you're not trying to sneak something past people. You're pointing it out and saying, oh, don't make this mistake because I don't want you to get confused. This is a problem that you see regularly in what are called pictographs, which are like people try to get really clever and come up with really cutesy versions of representing statistics. So you'll see this sometimes where people use some clip art or some kind of stuff to represent the amounts. The problem is this doesn't work because this is probably meant to represent double. Is it double? because it's twice as long and twice as tall. But when you take a shape and you make it twice as long and twice as tall, you've now made it 4 times what it was. It's not twice what it was, it's 4 times what it was. So look at the area of this is like 4 times what this is, but it's still twice as long. That's why we use bars. In histograms and bar charts, we use a bar because it only changes in the vertical direction, not the horizontal. Once we start changing things with two different dimensions, our brains just fall apart, right? Everyone's seen those videos where they take 2 different like shapes of, say, like a container, and you're like, oh, that one on the left is way bigger than that one on the right. And then they pour the water from one to the other, and they're the exact same volume. That's how it works. Our brains are not good. As soon as 2 dimensions are varying, our brains are not good at keeping up. Okay? So just basically don't use stuff like this. Don't use cute pictures. Use bars or use actual geometric shapes when you're making your... It doesn't make it better. It might look cuter, but you're actually confusing the information. Okay. Where are we? Right. Okay. And then I wanted to show you a couple things on StatCrunch. Where was I? Let's go over to StatCrunch. Is there any questions so far with any of this stuff? No questions so far. Okay. So let's go over to StatCrunch. StatCrunch has some interesting little simulations you can play around with. And the reason I'm showing you this is because we talked before about the shape of your data. And what you're going to, there's a section on probability coming up. You have to understand at least a basic understanding of probability in order to make sense of statistics. So if you can start making that connection between probability and the shape of your data, it's going to help. So let's see, where did the applet go? Let's say we want to take simulation of dice rolling. Okay, so this lets me play around and pick some different stuff. So I've got the number of sides on a dice, so 6-sided dice, but we could change it since it's just a computer program. We could change this to be, 30-sided dice, like someone's playing Dungeons and Dragons or something like that. And then we can change the number of dice to roll. So we'll just start with a standard dice. I'm going to roll it 1 time. And then there's a few different things we can look at for the tally. So let's ignore that for now, and let's compute it. So this will let me simulate flipping a coin. Let's make sure we get that in there, right? So you can see it's kind of slow if I just do it. Okay, 1, I got a 6. Okay, I rolled a 6, and there's like a little animation. The 6 comes down. Okay, I want to do 1. Oh, I got a 3 this time. And then the animation takes a while to go down. Okay, so we can kind of see how this works, right? Why don't I just do 5 at once? Okay, let's do 5 runs. Okay, so look at this. Look, so we've only done a small number of rolls, 7 rolls, and yet I've got a bunch of 4s. I've got way more 4s than 2s, right? But that's because we've only done a few. As we do lots and lots of rolls, we expect this to look more like that uniform shape that we saw in the book, right? That uniform shape. So let's get to where, like, we're pretty uneven here, right? But again, small sample size. That's why in stats, we like our N to be big, the sample size to be bigger. What if I do 1,000 runs? See how they're all roughly the same height now? Do it a few more times. Let's just do, let's get around 10,000. Okay, 10,000 rolls. You're not seeing one of these be like twice as tall as the other, right? Sure, there's some variation. I've had 1,726 5s, and I've only had 1,635 4s. But they're all roughly the same amount, right? So for equal outcome events, we're expecting this uniform distribution. Okay, so what if I change it? Let's do a different one, because sometimes a small change in what you're talking about creates a big change in the data. So if I go to here, I do, what are we doing? Dice rolling, except now I'm going to roll 2 dice, and we're going to look at the sum of those 2 dice. And then we're going to see what the shape of that data looks like. All right, let's do 5. Notice there's more outcomes now because we're adding the 2 dice. I'm rolling 2 dice and I'm looking at the sums. So what are possible? The lowest you can get rolling 2 dice is 2. The greatest you can get rolling 2 dice is 12. Okay? So let's do 1,000 runs. Oh, that's kind of weird. Look at that data. That doesn't look uniform. Aren't we doing the same thing we did a minute ago? No, we're not doing the same thing we did a minute ago. And this might even look normal. It's actually not normal. It's not really bell-shaped. It's more like triangular-shaped. But that's kind of tricky to tell. Let's just get up to 10,000. Okay, so why is this different? Why is it different? Well, when you roll 1 dice, all outcomes are equally likely. You're as likely to get a 3 as you are a 5. But when I roll 2 dice, the outcomes are not equally likely. Right? Why is that? Well, how many different ways are there to roll a 2 when you roll dice? There's one way that you can roll a 2. That is, you roll the dice, both dice come up a 1. That's why you don't see very many of them. There's only one way to do that. Same with 12. How are you going to get a 12? You get 2 6s. How many different ways can you get a 7? Well, you could get a 6 and a 1. You could get a 5 and a 2. Let's see, 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. So there's 6 different ways of getting that, right? Because you make it like they're different colored dice so you can tell the difference. There's 6 ways to do it. So you're actually 6 times more likely to get a 7 when you roll dice than a 2. This is actually the basis of the game craps. If you've ever played craps in at gambling, right, in Vegas or Reno or something, that's what the game of craps is all about. Is people are trying to get 7s, and some people are trying to get not 7s, and you're playing the probabilities of how this works. So even though this might seem like the 2 things we just looked at are the same, the probabilities are different, right? And you get a very different shape to our data when we look at it. Okay, so you kind of want to tune into that and try to start figuring out how that works. Okay. So I will have office hours on campus today from 11 to 2. You're welcome to stop by. Ask me questions about your questions. I do have office hours tomorrow on Zoom. So if you're uncomfortable going to campus right now, which is totally understandable, I'm not thrilled with going to campus myself, and you'd rather talk to me in Zoom tomorrow about your questions, feel free to do that. Please make sure you are taking care of your questions since they are due tomorrow. People who have already submitted their questions, feel free to go in and edit them. I think those couple comments I made might make your questions a little bit cleaner. But get together with your groups, try to figure out what you think, and then if like I have groups that are right now trying to set up Zoom meetings with me so that I can meet with them and talk to them about stuff, that's totally fine. But don't wait till the last minute. If you wait till 4 o'clock tomorrow to try to meet with me, that's probably not going to happen, right? Because I probably won't check my email after 4 o'clock. So get a hold of me today, get a hold of me tomorrow morning, and I'll see what I can do to help you out with those questions, but they are due tomorrow. Every single person who wants credit for the questions has to leave a comment in the discussion, right? You can't just go, oh, but like Sarah mentioned that I'm just making up these names, but like, oh, Sarah mentioned me in her post. That's not how you get credit, right? You get credit by leaving a post. If your group wants to split up the questions, you got 3 people, 6 questions, and you each post 2, that's fine. However you want to do it. Okay, but if you don't leave a post in the discussion, you will not get credit for the assignment. All right, so it's easy to do. Just leave the post with your question in there. Okay, so anyone who has questions for me, feel free to talk to me after class. So if you want to hop over into Zoom and talk to me right now, we can do that. Otherwise, thanks everybody. Continue working through, watch those due dates. Where are we with stuff? So September 30th. So we've got a little, not too much time before stuff's due. 10th, you got almost a week. Make sure you're working your way through chapter 2 here. Oh, and then one thing I wanted to mention. So at the end of October, I had to change a due date because somehow when I changed all the dates, somehow chapter, was it 5? No, it was 4. The dates for 4 were too early. Like it was due sooner than it was supposed to be. So I moved it to the end of the month, but just realize you're going to have 3 chapters due right around the same time. October 24th, got a chapter due. October 25th, the chapter is due, and October 26th, the chapter is due. And you might go, well, that's unreasonable. We've got homework due 3 days in a row. Right, but that's 22 days from now. So what you want to do is start working through the chapter 4 now, or chapter 3, right? Finish up your chapter 2 by the 10th, and then make sure you're progressing. Don't wait and go, oh, I have till the 24th, because then all of a sudden you're going to go, oh, I have a day to do chapter 4 and a day to do chapter 5. No, work on it now so that you're working through that stuff, okay? Otherwise, you're going to find yourself stressed out. Okay, thanks, everybody, and I will see you later.